the tangent and cotangent functions we can shift in the same way that we would shift a sine or a cosine or any other function. So we have this a tangent of bx minus c plus d. So this bx minus c inside the function, that's going to deal with our horizontal changing. We're going to be horizontal stretches and shrinks and shifting around. Same thing over here with the cotangent. So to graph these, there's a few things that are important to know. First of all, the period. The period of both of these is pi over the absolute value of b. The phase shift is the x value that gives you a 0 inside the parentheses. Okay, so that is x equals c over b. So our phase shift is c over b. And the phase shift is useful because it kind of gives us a starting point for the function. It really just describes the horizontal shift that has occurred. And then we have the asymptotes, and these are different for the two functions. A tangent typically has asymptotes at negative pi over 2 and positive pi over 2. And to find the asymptotes, if we just remember that, we can find the asymptotes of the shifted function by taking this inside the parentheses and setting it equal to negative pi over 2 and positive pi over 2. So we can take bx minus c and set it equal to negative pi over 2. Or positive, and I'll actually just do a positive or negative. Okay, we could set it equal to both of those, and then we could solve for x. So if we add c, we get bx equals c plus or minus pi over 2. And then we can divide by b, and we get x equals c over b plus or minus pi over 2b. So you can see that this is actually obtained by our c over b is the phase shift, and then we just add or subtract half of the period. Okay. So those are our asymptotes. X equals the phase shift plus or minus our half of our period. Now for cotangent, cotangent typically has asymptotes at 0 and at pi. So we can do the same thing where we take bx minus c, set it equal to 0 or pi. So I'm going to have to do this separately. Bx minus c equals pi. And so we can add the c and get bx equals c, and then divide by b and get x equals c over b. And then here, if we add c, we get bx equals c plus pi, and then divide by b, and we get x equals c over b plus pi over b. And so here we can see that it also revolves around or is dependent on that phase shift. It's just the phase shift, it gives you one asymptote, and then you get another one if you just add the period. And so our asymptotes are, we've got c over b, okay, x equals c over b, and then you can add any multiple of the period, pi over b, okay? So I just wrote a couple asymptotes, but you can actually do any multiple of that period, right here. And then here you can do that c over b plus or minus pi over 2b, and then from there you can add any multiple of the period. Typically we will just draw one period, and then we know that repeats, so we don't need to really worry about that k so much, or this k pi over b term.